Alrighty, so this video will be your chapter 4 practice problems. So our first problem, Justin draws his compound bow and shoots an arrow. The 23-gram arrow leaves the bow with a velocity of 88 meters per second. The power stroke of the bow is 57 centimeters. That is, the bowstring exerts a force on the arrow through a displacement of 57 centimeters. The peak draw weight of the bow is 312 newtons, or in other words, the max force that the archer has to exert on the bowstring. So our part A, we need to find kinetic energy. So kinetic energy is equal to 1/2 mass times the velocity squared. So they gave us a mass of 23 grams, but we need that kilograms. So 0.23 kilograms. They gave us a velocity 88 meters per second. And that's what we need for this problem. So Ke equals 1/2 times 88 times 88 squared times 0.023. Plug in a calculator. So our kinetic energy is going to be 89.056 joules. And that's part A. So for part B, they want us to calculate how much work is done. That up. So an equation for work that can be used, work is equal to sum of the average force times displacement, which is also equal to the sum kinetic energy, which is Ke final, Ke initial. So if you recall in that first problem we just did, we just solved for our kinetic energy. So in this case, our work is also going to be 87 joules. So for part C, they would like us to solve that average force. So F with the bar over the top times displacement. We want that. Oh, can't see that. Work, average force, displacement. So we just determined that our work is 89 joules. And they gave us a displacement of 57 centimeters, which we want in meters, 0.57 meters. Do some rearranging. So plug in your calculator, 89 divided by 0.57, you get 156 newtons. So we're going from, joules over meters. So another way you can write joules is as a Newton meter, they're equivalent. So if we have a Newton meter over a meter, our meters are going to cancel, leave us with newtons. And that will do it for our first problem for chapter 1. Alrighty, for our second problem of chapter 4. So at the top of a giant swing on the gymnastics high bar, Candy's velocity is 1 meters per second, and she is 3.5 meters high. If Candy's mass is 50 kilograms, what is her total mechanical energy at this instant? So to calculate our total mechanical energy, that is also the same as kinetic energy plus potential energy. So kinetic energy, 1/2 mv squared. So 1/2 50, so kilograms, times 1 squared, or 1. So kinetic energy going to be 25 joules. So that's only half of it. So to get our potential energy, it's mass times the acceleration due to gravity times your height. So we got 50 times negative 0.81 times 3.5. My mistake for this, our 9.81 is going to be positive. So that is going to give us 17.6.75 joules. So then to get our total, we've got our 25 plus 17.16.75, which gets us 1741.75 joules. And that will do it for our Chapter 4 problem.